Three horizontal forces of magnitude 8, 15 and 20 newtons act at a point. The 8 Newton and 15 Newton forces are at right angles. The 20 Newton force makes an angle of 150 degrees with the 8 Newton force and an angle of 120 degrees with the 15 Newton force. Calculate the components of the resultant force in the directions of the 8 Newton and 15 Newton forces. Calculate the magnitude of the resultant force and the angle it makes with the direction of the 8 Newton force. The directions in which the three horizontal forces act can be altered. State the greatest and least possible magnitudes of the resultant forces. Okay, so that's the question then. Here it is here in summary form. I've drawn the picture below. Calculate the components of the resultant force in these directions. So vertically then, let's resolve the forces. We've got 8 minus 20 of this angle here. So I'm just going to put the angle in. This will have to be 30, won't it? Because the whole thing is 120. 20 cos 30. Cosine 30 is root 3 over 2, which is 8 minus 10 root 3. So we've got 8 minus 10 times the square root of 3 decimal minus 9.32 newtons, and that's the three significant figures. Now along the 15 Newton direction, we've got 15 minus 20 of this angle component here. This is 60, isn't it? So 20 cos 60 is the same as sine 30, which is a half. 15 minus 20 times half is 10. 15 minus 10 is 5 newtons. So basically our force is 5 newtons along. Oops, a bit long. 5 newtons along, and it's 9.32 downwards. That's the resultant force, so it acts down here. If we label this with R, so on the picture it will act down here. And this will be alpha. Tan alpha is equal to 9.32 over 5. So alpha is equal to then. So now let's just go back to the question, because we're just getting ahead of ourselves here. So what's the next part of the question? Calculate the resultant force, magnitude, and the angle it makes with the 8 Newton force. So we need the magnitude. So here, the resultant force as a magnitude then is equal to the square root of the two sides squared. So that'll be 5 squared plus the 8 minus 10 root 3 squared is equal to, so we got it here, so let's square it, because that's the same thing squared, plus the 25. So there's that. Now square root answer. 10.576. 10.5. So it's 10.6, isn't it? So three significant figures. And that's newtons. 10.6 newtons. So the angle alpha, we said it was this. So let's tap that in. So it's 10 root 3 minus 8. So 10 times the square root of 3 minus 8 is the top number. Divide that by 5. Divided by 5 equals, that's the tangent then. We want shift tan of that. So inverse tan of the answer equals 61.8 degrees. 61.8 degrees. Here, R is equal to that, and angle, the angle to the vertical 8 Newton force will be 90 plus the 61.8 degrees, which is equal to 151.8 degrees. So that's the angle then for part 2. Now state the greatest and least resultant forces then. So we can change the angles of the 8 and the 15. We've got an 8, we've got a 15, we've got a 20 down here. And these forces can be changed in any direction we wish. So to make them the biggest possible, we'd want them in all the same direction, wouldn't we? 20, 15 and 8. So this is part 3. So the maximum is equal to 43. Whereas if we think about these as being like vectors, so if we had a 20 force here, say, then the 15 could be here in such a way that we form a triangle. Because we can form a triangle like so. It's not necessary, it's not 90 degrees or anything, it's just 3 sides of a triangle. We can draw a 3-sided triangle. One side has 15, one side 8. Because these are 23, then we can form a triangle. Had this length been longer than 23, we couldn't have formed a triangle like this. So the resultant force here, if we have the 20 acting in that direction, would be 0. So put the 20 down in this direction. So we got minimum force then is equal to 0 newtons, because they can make up 3 sides of a triangle like so, like illustrated over here.